Hi, good morning. Welcome to integration class. Today we'll discuss few more problems based on the last form which we studied. That means integration of dx divided by root of a square minus x square. That is equal to, hope you remember everyone, it is equal to sine inverse of x by a plus c. Okay, very interesting form. So we'll discuss one by one form problems. So first problem we'll see integration of dx divided by root of 15 minus or 5 minus 8x square. Okay, so what you supposed to do? So x square have a coefficient 8. Better you take out from integration. How do you take? So integration of dx, when you take out 8, okay, so it will be, so I can write root 8 into 5 by 8 under root. So when you take inside, it will be 8 get cancelled, it will be 5 minus 8 only, 8x square. Okay, so minus x square. Alright, hope you understood this step, it's very important. Now again I can take out this root 8 from integration. So dx divided by root of 5 by 8 we could write as 5 by 8 under root whole square minus x square. So it looks like a square minus x square. Am I right? A square minus x square. So my a is just 5 by 8. Even you can write as 5 by 8, no issues. So my answer is sine inverse of 1 by root 8. Root 8 you could write as 2 root 2. Am I right? So x divided by 5 by 8. So it is 5 by 8 plus c, or you could write as 1 by 2 root 2 sine inverse of so my a is root 5 by 8. Okay, so you should be very careful. So it will be root 8x divided by root 5 plus c. Be careful. Okay, so we'll see one more problem. Write the form at the corner so it is better. So integration of dx divided by root of a square minus x square equal to sine inverse of x by a plus c. Second problem we'll see integration of cos x dx divided by root of 4 minus sine square x. Okay, so what we better is supposed to do is substitute t as sine x. Okay, so what happens? Dt equal to cos x dx. I'll get the numerator as cos x dx. So rewrite this. So I could write this as cos x dx divided by root, instead of 4 I could write as 2 square minus sine square x. Now it looks like this form. Alright, now replace cos x dx as dt. So dt divided by root of 2 square minus t square. Absolutely it looks like this. So I could write sine inverse of x, instead of x I could write t by a is 2. So sine inverse of t is replaced by sine x, that is sine x by 2 plus. Hope you understood the steps, very important. One more problem we'll see, nothing special. So when you see, you should realize, okay, this looks like this form, so I could substitute. You might have asked doubt, okay, how I feel like I suppose substitute t equal to sine x. So this is coming by practice, no other method. If you solve a number of problems, then you realize mind will flick. That's what I am telling. Practice is very important in mathematics. If you practice series of questions again and again, okay, so we are going in a very sequence, very systematic format. That is most important. Organized way is very important. I mean to say, I bifurcated each problem under different forms. Okay, this is most important. Otherwise, integration is more hectic. Okay, I mean to say you will totally feel confused. So to avoid such confusions, I made a different variety of forms throughout integration. You might have observed I categorized all problems under certain forms. Okay, so that it is easy. This is one way of making mathematics very simple. You should be very organized, one after one. It should go in a sequence way. Even problem also. Usually the first beginning I used to pick the smaller problems. As the class goes, I used to pick the different levels of problems, so that your approaches go very systematically. Okay, that is most important to remember different variety of problems. So your memory capacity will keep increase if you organize, substitute, divide each categories. Okay, so you go follow what I am doing in the class. Similar way, you really feel very comfortable at the end of the calculus class. Okay, now third problem we'll see. So integration of dx divided by 1 minus e to the power root x under root. What you're supposed to do is multiply numerator and denominator by e to the power minus x. Very important, e to the power minus. What happens? You see, e to the power minus x dx divided by e to the power minus x under root 1 minus e to the power 2x. So listen, one very important thing. For example, 1 by root t is there, then 2 root t is there. So when I want taking inside 2 inside the square root or radical sign, what happens? How I can take? It should be square. That means 2 square into t. That means 1 by root 4t. Hope you understood. Similarly, if I want to take out 4 outside, you should apply square root for that particular constant. That means square root of 4 is 2 root. It will be same. So this is very important step, and this is one simple steps, but people are confusing. If you want to take anything inside the radical sign, you should square. Okay, then only it is true, because when you take square root, you will get the original form. Okay, keep it, remember. Now I want to take inside the radical sign. What happens? This is numerator as it is. Now I am taking inside, so it will be square. So what happens? E to the power minus 2x minus, see now you see, e to the power 2x into e to the power minus 2x. What happens? E to the power 2x minus 2x it can see e to the power 0. E to the power 0 is 1. So I can write 1. So you should not confuse. Okay. So now what you can do is substitute t as e to the power minus 6. If you differentiate this, what happens? Minus e to the power minus 6 into dx. Dx I am taking this side. So now you see, rewrite this e to the power minus x dx. This I could write as e to the power minus x whole square minus 1. Am I right? E to the power minus 2x equal to e to the power minus x whole square. Now you can, it will be easy. So here minus sign is there is no minus sign. So better you write minus dt equal to e to the power minus x dx. Now it was simple. So what happens? This will be integration of minus dt divided by e to the power minus x as t square minus 1 under root. Square root is there. Okay. Square root, we should not forget the square root. Now this is, again I can take minus sign outside, root of t square minus 1. Again take minus sign. So this looks like a square minus x square minus a square. So better apply the other form, that is minus log of t plus root of t square minus. This is equal to minus log of t e to the power x minus x plus e to the power minus 2x minus plus. Hope you understood this. So very important step is this multiplying divide by e to the power minus x, and then taking inside the radical sign and writing in this format and substituting as e to the power minus x. So if you do 2-3 times, you really feel okay, I supposed to follow this method. So once you stick these things, so this is one of the good example. Okay, definitely you might expect this kind of problem in CET and all. Very interesting and very simple. Next problem we'll see. So integration of 2 to the power x divided by 1 minus 4 to the power x dx. This is 4 to the power x. Integration of 2 to the power x dx divided by root of 1 minus 2 to the power x whole square. Substitute t equal to 2 to the power x dt equal to 2 to the power x log 2 into dx, but in the numerator here it is available 2 to the power x dx. So dt by log 2 equal to 2 to the power x dx. Now everything you can substitute, it is simple. So dt by log 2 root of 1 minus t square, am I right? So 1 by log 2 you can take outside into apply integration for this sin inverse of t. So 1 by log 2 into sin inverse of t is what? 2 to the power x plus. So if you remember the differentiation of constant to the power x, then it will be easy. If you forget this, then gone everything. So hope you understood all the steps. We'll move on to the next problem. Sixth problem we'll see. Fifth problem. So x square dx divided by root of x to the power 6 minus 1. So better you rewrite this as x square dx divided by root of x cube to the power square minus 1. Am I right? So substitute t equal to x cube, dt equal to 3x square dx, numerator x square dx. So dt by 3 equal to x square dx. Substitute back. So integration of dt by root of t square minus 1. Again we apply log form. Okay, it is log of modulus of t plus root of t square minus 1. That is equal to, so it is 1 by 3, take outside 1 by 3. So 1 by 3 log of t is x cube. So x cube plus x to the power 6 minus 1 plus modulus under modulus. Hope you understood this. Okay. So I am applied the other form, that is integration of dx divided by x square minus 1 under square. It is log of x plus root of x square minus 1 plus and this one. We'll see the next problem. Integration of dx by root of 2x minus x square. Little tricky problems. When you see at the beginning, suddenly it will look like different form, but we could observe neatly, so we can convert this into the right form. So what I'll do is I'll take minus sign outside. Integration of dx divided by minus, this will be x square minus 2x. Now consider only this minus x square, minus of x square minus 2x. Can you write in a plus b whole square format? We try. So this will be x square minus 2 into a is x. So again it is, I want finally 2 only. So what I do is 1. So it is b is 1. So 1 square. Now this I could write as x minus 1 whole square. Am I right? But I extra 1 added. Okay. Actually, it is not 1 plus 1. When you open bracket with minus sign, it will be minus 1. So it is minus 1 you added. So I'll compensate with plus 1. So now things will be very easy. So what I can write is minus of. So this will be x plus x minus 1 whole square. When I expand this, I am getting this. Okay. Plus 1. Is it true? Check, cross verify. So here I am getting plus 1. When you open bracket, so this become minus 1 and this become this plus become minus. Am I right? So when I open, okay, this plus become again minus. So it is minus 2. No need. So better you keep this is minus 1. Minus. Now it will plus plus minus get cancelled. Am I right? So very careful when you writing some structure. So hope you are getting this place. So you expand, if you want to expand, you expand. Minus, this is x square minus 2x plus 1 minus 1. For this again I have a flower bracket. Minus x square plus 2x minus 1, this is plus 1. Now it get cancelled. Final left out is x square minus x square and plus 2x. So careful, I am doing very systematically because you should not confuse. That is a motto. So very important this step, manipulation step. So what I can do is I can write this as minus sign. I'll take a dx by root of. So I can write as x minus 1 whole square minus 1. Okay. So substitute d as x minus 1 dt equal to dx minus, so it is dt divided by root of d square minus 1 x square minus 1. So minus log of modulus t plus root of t square minus 1 plus c, or minus log of modulus of t equal to x minus 1 plus root of x minus 1 whole square minus 1 plus c. Hope things will be very clear, very systematic. So we'll see the next problem. We'll see the last problem. Integration of dx divided by root of 15 minus 6x minus sin x square. Again, simplification is very important. So first I'll rewrite this by taking minus sign outside. So what I can write is 15 minus, I'll take outside, it will be 9x square plus 6x. Am I right? Just I'll put a bracket so that minus x square will happen and minus 6x. Now I'll consider only this part, 9x square plus 6x. So I'll rewrite this 9x square plus 6x as 3x whole square plus 2 into 3x into 1, so it is 6x. So extra I'll add 1 square. So I added 1 square, I subtract 1. So now first part, what happens? 3x plus 1 whole square, okay, minus 1. Is it clear? Now I'll substitute here, dx divided by root of 15 minus, instead of this I'll put a flower bracket, 3x plus 1 whole square minus 1. Now see, 15 minus of, when you open bracket, what happens? Dx divided by root of, very careful, minus 3x plus 1 whole square. This is plus 1. Am I right? See, minus become plus when I open the flower bracket. Now plus 1, 15 will become 16. So this is 16 minus 3x plus 1 whole square. 16 you could write as 4 square, dx divided by under root 4 square minus 3x plus 1 whole square. So I substitute t as 3x plus 1 dt equal to 3 dx, or dt by 3 equal to dx. So my integration becomes dt by 3 divided by root of 4 square minus t square, x square minus, say, a square minus x square. So 1 by 3 sin inverse of t by a is 4. So 1 by 3 sin inverse of t is 3x plus 1 by 4 plus. So this is the final answer. So very important thing is this manipulation, the inner things very systematically as per the available form. So if you remember the different forms in your mind, then you will see the problems, you realize that, okay, I supposed to convert like this, okay, or you start to convert and it will be flick, okay, so I can follow this format. If you are not remember the form, okay, then you will stuck, you don't know what to do, and you will spend more than 5 minutes. Again you are erasing everything, cutting, again you are doing. So process will continue 2-3 times, you are losing your 15 minutes. Instead of doing again and again in exam, my sincere request is you do at home now 2-3 times. You invest your 5 minutes or 15 minutes or 30 minutes to understand one concept, okay, and that will really help you in exams. Exam only you one time you do, so that you can save time. You have only 3 hours, within that you have to finish. In competitive exam only 2 minutes. So you think how many times you are supposed to practice. If you are not practice now, you start practicing your exam again and again. You lose your marks, you lose your time, you lose your rank, everything. You lose your seat in good engineering college or medical college. So to avoid all those things, better you practice now and try to remember all the forms and techniques and rules. Definitely you are in the place, your dream place. That is what we need at the end of the day. So my sincere request is, we solved different levels of problems, more than 100 problems, 200 problems. By now you might have solved more than 150 problems in integrations. It is a huge remark, okay, and I given so much exercise to you. So if you are really done all the things, really you will be master in integration. We'll see you in the next form and different variety of problems in the next session. Hope Hope you understood this session. Practice well. Try to get a pitch of integration. All the best. Thank you.